Welcome to Study Loop.
Here, we are asked to think about a reaction that occurs in the gas phase and is exothermic. For these 5 different conditions, how is the equilibrium constant K impacted? First, removing a reactant. While we know from Le Chatelier's principle that removing a reactant shifts the equilibrium of the system itself, the equilibrium constant itself, K, remains unchanged. That's because it's an equilibrium constant, and so it doesn't actually depend on the conditions you apply to it at a given time in terms of concentrations, or in this case, partial pressures of the gases in your system. Likewise, removing a product would invoke Le Chatelier's principle, but you still would see no change in K, as it is an equilibrium constant. Similarly, if you decrease the volume of your system, we know that that would shift equilibrium towards the side that has fewer moles of gas. And so while this might impact the exact composition of the system that you see, the equilibrium constant itself will not change. This is because equilibrium constants are only temperature dependent, not pressure dependent. But they are temperature dependent, so now we have to think when we get to decreasing the temperature. We're told that the reaction is exothermic. When we hear exothermic, we can think of heat as a product. If we add more heat, then, we are inhibiting this reaction from going forward. And so, the reaction will actually shift back towards the starting materials. Therefore, the reaction constant K will decrease. Finally, adding a catalyst. Adding a catalyst tends to speed things up, but ultimately there is no change in K, since it's just a description of the ratios at equilibrium.